All right, welcome back. We are on 7.6 day one. We're going to skip these review questions because the first one can't do anyway right now because we haven't covered parametric equations. We can do the second one. We'll do it real quick. The vertical asymptote here, this is the HK form, so that means x is going to equal whatever makes the bottom 0, which would be -2. And our horizontal asymptote, well, that would be, in this case, an HK form of a graph. That means y is equal to, well, HK form means you'd have +0 out here on the end. So y would be 0. That'd be your horizontal. Today, what we're going to talk about, solving linear programming word problems using graphing techniques. Now, linear programming, it's the process of maximizing or minimizing a function with certain constraints. For example, only a certain amount of money or time may be available in specific real-life situations. These limitations can affect things such as profits. Now, the steps to doing this. First of all, you need to graph the constraints. These are going to be linear inequalities. You're going to shade the appropriate regions. You're going to list the vertices of the polygon that gets formed when you're done. You're going to plug those vertices into the function you are trying to maximize or minimize. And then the highest y value is the max. And the lowest y value, obviously, would be the min. So one of the things you're going to need here, you got to find something with a straight edge. Use your ID, use the side of your calculator, whatever it is, but you need to draw some straight lines. These first couple, not such a big deal. But when we get to tomorrow's work, the next lesson, if you don't draw really straight lines, that's going to cause you to maybe miss the points that you need, and that's going to be an issue. So make sure that you are using something with a straight edge. Don't just freehand draw these. Here it says, given the following constraints or inequalities, that would be all of these right here, and the objective function f of xy is equal to 3x plus 4y. Use the process of linear programming to maximize the function f of y. So this function is also labeled as z, and that's what we'll see it later. So first things first, we have to graph this. So looking at this picture, we first need an x and a y axis. Well, you always usually start with these two right here, because this is saying x is greater than or equal to 0, y is greater than or equal to 0. So we are talking about the first quadrant in terms of those pieces. So I'm going to go right here, and I'm going to just use the edge of this picture as my XY axis. Now these are both equal, so they're solid lines versus dashed lines. Now we're going to graph each of these next ones. And when we graph the first one, we're just saying it's y is less than or equal to, this is going to be -x plus 6. So we're going to go to 6. I'm labeling all of these by ones. So 1, 2, 3, all the way up. So 4, 5, 6, that would be right here. And usually the way you do these, I'm only writing this because I want to see what that is going to happen with that symbol. Right now the symbol says less than, so it's going to be below the line. But when you graph them, a lot of times because they're in the standard form, if you just put 0 in for one variable, you'll figure out what the other one is. So I already know that if I put in 0 for x, then y would be 6. So now I'm going to put in 0 for y. X is also 6, so I would go across the bottom here. I'm also making this 1, 2, and 3. So 4, 5, 6, that would be right here. You have your two lines. Use something straight and draw your curve or your line. I'm going to do as best I can here because I don't really have something completely straight, but this will work. Okay. That's the first one, and it's saying less than that. And then the next equation, we're going to do the same thing. I'm going to put zeros in. So if I put a 0 in for y, then 2x is equal to 14, and that means x would be 7. So I'd go to 7, which is right here. And then if I put in a 0 for x, y is going to be 14. 14 is all the way up here at the top. So now you have those two, and you're going to draw your straight line here. Like I said, do your best. I have a little problem with it just because of the screen. So I'll do what I can to make this as straight as I can. And there's that one. And this one also says that y would be less than. So what we're talking about is less. We're less than the blue line. We're less than the red line. So we're actually talking about everything right here. This would be all that area we are interested in. So following the steps, it said to do all of those things and then shade. I did that. It said list the vertices of the polygon that gets formed. Well, the polygon that's going to get formed here is going to be the following. It's this one right here, this one right here, and this one in the corner. So listing the vertices of those, we would have 0, 6, 0, 0, and 6, 0. And now they want us to find the max. Where does that occur? Well, if I look at my function that they gave us, this was z. Remember, this would be z right here. So z would equal 3x plus 4y. So that just means take your vertices, plug them in, and see which one gives you the biggest result. So x is 0 in this one, so it'd be 3 times 0 plus 4 times 6. That gives you 24. This one would be 3 times 0 plus 4 times 0. Well, that's going to give you 0. And then the last one is going to be 3 times 6 plus 4 times 0. That gives you 18. This is the largest one, so the max is 24. And it occurs at which vertex? Well, it occurred at 0, 6. So that would be the values for all of those. Not terrible. Just draw some lines, shade the regions you need to, find your points that create your polygon, and then work from there. Let's try the second one here. This one says maximize the objective function z equals 8x plus 19.5y with the following constraints. So they are now once again saying that we are going to have x being greater than or equal to 0 and y is greater than or equal to 0. So I'm just going to do the same thing for this one. I'm going to start by just making this the y part of it. Make this the x part of it. So I took care of those two. Now I'm going to graph the rest of this, starting with the first one. It says x plus y is equal to, or is greater than or equal to 6. So this one's saying it's going to be bigger or above this line. So if I put in a 0 for x, then y is going to be 6. So once again, I'm just going to start with these and say, here's 1, here's 2, blah, blah, blah. So 1, 2, 3, 4, 5, 6. Here's this one. And if I do the same thing with y being 0, then we have 1, 2, 3, 4, 5, 6. That's this one. And so once again, just like in the last problem, we actually have a picture that's going to look something. Hold on a second. Just got to get this thing lined up. Something like this. Still a solid line, but it's saying that I have to shade above that line. So just be cautious of when you do these. The next one, same idea. I'm going to put 0 in for x. That means y is 12. That means I'm going to be right here. And if y is 0, then this one would be 6, which means I'm on top of this point right here. So now I have that point that I need to graph. So I will do my best to graph that one as well. There's that one. This one says less than. Y would be less than that. So it's telling me that I'm shading all of this region right here. That would be the part that gets shaded. So there would be the points there. Then I need to do just what I did before. They want me to find the vertices of this polygon. So I would be looking at those vertices. The vertices would be 0, 6, 0, 12, and 6, 0. And then if I use my z formula here, it's saying I'm going to take 8 and I'm going to multiply it by 0 plus 19.5. I'm going to multiply that one by 6. I'll get an answer. That's for z1. z2 for the second point, this one's going to be 8 times 0 plus 19.5 times 12. And the last one, z3, it's going to be 8, 0, oops, not 8, 0, 8, 6 plus 19.5, 0. And then we do the math here for each one of these. For those, it's going to be 6 times 19.5. What is that? 7. Looks like 117, I'm guessing there. I don't know exactly what that is. Give me 1 second. I will bring up my calculator so that I can do this. Except I can't do it on here. So 1 second. All right, calculator. Sorry, I got to get this thing open. So here's my calculator. I'm going to put in 19.5 and I'm going to multiply that by 6. Should have believed myself. 117. Then 19 times 12, so 19.5 times 12. Obviously, this is probably going to be the biggest one, and I didn't do that. 19.5 times 12. I said plus 19.5 times 12. 234. And then the last one is 48. So obviously this is what's going to get maximized here. So they're saying that the max volume or max is going to be at 234 and it occurs at 0, 12. So this would be our entire answer. All right, hopefully that makes sense. I know these seem kind of silly because they aren't really, it's always the top number, the largest one away from the 0. In both of these, because the x coefficients were smaller than the y coefficients, it always ended up being on the y-axis. But now we're going to be looking at a different problem here. A manufacturer produces 2 models of mountain bikes. The times in hours required for assembling and painting each model are given in the following table. Manufacturer is subject to the following constraints. The assembly department can work a maximum of 200 hours per week. So you've got X's and Y's here. We'll call these our X's and we'll call these our Y's. So the first thing we want to do, we've got to write the equation. Now they aren't giving you the equations, you got to write the equations. So I'm going to start with the simple one. I said that they can only work a maximum of 200 hours, and that's in the assembly. So 5x plus 4y has to be less than or equal to 200. And then it said the paint department can work a maximum of 108 hours a week. Well, that means 2x plus 3y has got to be less than or equal to 108. And then what are our other constraints? Well, we do have the same constraint of x being greater than or equal to 0. That makes sense because we're talking about time. You can't have negative time. And then y is also going to be 0. So here are the constraints that we have. Now we're going to actually graph this thing. I'm going to do exactly what I did before. I'm going to start with the x and y. And then we're going to proceed from here. So I'm going to graph the first equation up there. When I graph that first one, if I put in 0 for y, I'm going to get 5x is equal to 200, so it would be 40. So now I've got to look at this and decide, how am I going to factor that one? And then if I do the other one, I'm going to end up with a 2x is equal to 108, and that's 54. So I've got to get to 54 here, and I've got to get to 40. Basically, those are the 52 for both sides, 40 for one, 30 for the other. So I'm going to have to scale this thing accordingly. So I'm going to look at scaling this thing by saying this will be 4. And then if I add 4, I get 8. This will be 12. If I add 4, I get 16. This will be 20. 24, 28, 32, 36, 40, 44, 48, 52. And that should get me where I want to be. This would also be 4, and then 12, 20, 28, 36, 44, 52. So I have all of those. Then I'm just going to graph this thing. So the first one, if I put in 0 for y, x will be 40. So I'm going to go over here to 40. Here's this one. And then if I put in 0 for x, then it's going to be that y is 50. So I've got to go to 50. That's this one right here. So this first one is going to run from 50 down to 40. And like I said, important here that you try to draw straight lines. Then I'm going to do the second equation. The second equation, if I put y equal to 0, then x is going to be 54. So I would go out to 54, which would be right here, kind of in the middle of those two, because the next one up would have been 56. And then if x is 0, then it's 3y is equal to 108, and that would give you 36. So that one is right here. And because I have those two, I'm going to graph 2 of those. And here's why you want to make sure that you can draw a good picture. Because I don't have these, I don't have an actual ruler that I can use on this. I kind of have to guess here, and I'm guessing that it's going through this point. But because I can't draw a super accurate picture, that's why you need to do so. So the polygon that gets formed, these are all less than, so it's going to be the area that falls in here. So hopefully we see that. That's the area that we're looking at. Now I need to do what? Well, it says you've got to find the vertices of the polygon formed. Well, the polygon that's formed from the shaded region is all of these particular points right here. So one thing you can do, and you probably should, is you probably should test that point. 20, looks like 24. Okay, you should test that point because, actually, was that right? 2024 or? Nope, see, I think I'm even farther away. I don't think that one would even work. So, looking at this one, let me see here what I would have done. Drawing it on my page, I actually came up with 24, 20. So that means this point actually isn't here. It's actually right here. That would be where that point is. So this is why I'm saying you've got to make sure that you can draw an accurate picture. Because if you don't, if you mess it up even a little, you're going to change the polygon. This one was for both the two equations. So one way to test it would be to plug things in and see if they work. I'm just kind of trying to point out to you that sometimes this could be a little bit messy. So just be careful when you do this. Just probably should come out to be an equal sign. This would be 120 and 80. That's 200. And then 48 and 60 would be 108. So it is this point right here. So you got to be careful when you draw these. Now, the vertices are going to be the following. 0, 0, 0.36. This one is going to be 24.20, and the last one is going to be 40.0. So those are the four. Now, we need the equation. Well, they didn't give us the equation, but they did say profits for model A are 27 and profits for model B are 18. So our Z equation here would end up being 27x plus 18y. And now we're going to plug in each one of those once again and test them all to see which one works. So I go here and I just say Z is equal to, this is 27 times 0 plus 18 times 0. That gives you 0. That's for Z1. Z2, that's going to be 27, 0 plus 18 times 36. That's going to give you 1,008. Z number 3, that's 27 times 24 plus 18 times 20. That's going to give you 1,080. And then the last one, Z4, that's going to be 27 times 40 plus 18 times 0, and that's going to give you, what is that? Oh, wait, I think I got a couple of these mixed up. That one should be 1,008. Sorry, I got that one in the wrong place, so sorry. 0.36 ended up being 648. 24.20 ends up being 1,008. And 40.0 ends up being 1,080. So what does that tell us in terms of our values? It's saying that they should plan on to maximize profits. That doesn't make any sense. 1 second. All right, so I thought maybe somebody gave me some bad numbers here. So we would maximize right here. That would be the max that we would see. So hopefully this makes sense. If you got questions, ask your teacher about them, and we will talk to you later. Bye.